Problem F6-3. Determine the force in each member of the truss. State if the members are in tension or compression. Please follow along in your textbook. The truss is composed of 4 joints, A, B, C, and D, and 5 members, member AB, member AC, member AD, member BC, and member CD. There are 3 reaction components. There is the roller reaction at B, which applies force purely in the y direction. And there is the pin reaction at D, which will have an x and a y component. There are also 2 loading forces at A and C. Members AB and CD are horizontal, so their tensions will act purely in the x direction. Members AD and BC are vertical, so their tensions will act purely in the y direction. Member AC is diagonal, and so in order to break its tension into components, we need to find the total length of AC. Member AC has a horizontal displacement of 4 feet and a vertical displacement of 3 feet. Using the Pythagorean theorem, this gives us a total length of 5 feet. Next, we will want to find the sum of forces equations for each joint. For joint A in the x direction, there are 2 members that will apply force in the x direction. Tension AB will pull it purely to the right, and tension AC will pull it up and to the right in a diagonal. To find the horizontal component of tension AC, we need to use the horizontal displacement of 4 feet divided by the total displacement of 5 feet, giving a coefficient of 0.8. In the future, I will not be doing this calculation, instead just giving the coefficient. So the sum of forces on joint A in the x direction is TAB plus 0.8 TAC. On joint A in the y direction, there are 2 member tensions. AC is diagonal up, and member AD pulls straight up. There is also the load of 800 pounds straight down. So the sum of forces on joint A in the y direction are 0.6 TAC plus TAD minus 800 pounds. On joint B in the x direction, the only thing applying force is member AB pulling it to the left. So the net force on joint B in the x direction is negative TAB. On joint B in the y direction, there are 2 forces. There is the tension BC pulling it up, and the reaction force at B pushing it up. So the sum of forces in the y direction on joint B is TBC plus RB. For joint C in the x direction, there are 2 members pulling it in the x direction. AC pulling it down and to the left, and member CD is pulling it directly to the left. There is also the load force of 200 pounds pulling it to the right. So the sum of forces on joint C in the x direction is negative 0.8 TAC minus TCD plus 200 pounds. In the y direction on C, there is member AC pulling it down at a diagonal, and member BC pulling it straight down. So the sum of forces on joint C in the y direction are negative 0.6 TAC minus TBC. On joint D in the x direction, there are 2 forces. There is member CD pulling it to the right, and there is the x component of the reaction force at D. And so the sum of forces in the x direction on joint D are TCD plus RDX. In the y direction, there's the tension in AD pulling it down and the reaction force in the y direction. And so the sum of forces on joint D in the y direction is negative TAD plus RDY. So we have a total of 8 equations and 8 unknown values. We can use any method we want to solve these equations, including the RREF method. However, there are parts of this problem that are easier to solve piecemeal. First of all, in this equation, sum of forces on joint B in the x direction, we can see that TAB must be 0. So I am going to highlight this equation to indicate that we have already used it. Now that we know that TAB is 0, the sum of forces on joint A in the x direction tells us that TAC is also 0. Now that we know that TAC is 0, we can use the sum of forces on joint C in the y direction to tell us that TBC is 0. So we already have 3 zero force members. These could be removed from the problem and the problem would be unaffected. All that's left are TAD and TCD. To find TAD, we can use the sum of forces on A in the y direction. We already know that TAC is 0, and so this gives us that TAD must be 800 pounds. Likewise, the sum of forces on C in the x direction, we already know that TAC is 0, so this tells us that TCD must be 200 pounds. Once again, we have not used these 3 equations, but the problem does not ask us to solve for the reaction forces, so we do not need to know these. The net result is that TAB, or that member AB, AC, and BC are all at 0 force. Member AD is under 800 pounds of tension, and member CD is under 200 pounds of tension.